piecewise function. So piecewise functions is is that you can represent a piecewise function on a table graph by evaluating values of x. So this is a piecewise function that you are looking at. And what you will notice is it says you can create a function having differently depending on the input of your x values. So when we are looking at this, this function has three different pieces. Is each one of them a function? Do they pass the vertical line test?
Yes.
Yeah. Each input x has one output y. Each input along here, x has an output y. Same thing here. Now, what we might not know is if this is a closed circle and this is open, or vice versa. But in our homework, you'll see that, okay? So, piecewise functions. We're going to watch this video. And so, as you watch the video, piecewise functions are given by different, if we think of that, what would you think? Different pieces or expressions is what we're going to talk about. So, if you look down here, these are going to be your expressions. So, a piecewise function is given by different expressions over various intervals. Okay, so piecewise is going to be an expression over the interval. It says to model these equations, you must include the expressions and usually what we are going to be talking about, their constraints, which is another name that we sometimes use are limits or restrictions. That's this part back here. So when we look at this graph, or we look at this equation, the constraints, that's going to be this part right back here, okay? Whereas our expression is going to be this first part. So as you watch this video, and it's about 5 minutes or so, and it's a pretty decent one as we are looking at this. So.
Piecewise function. In this lesson, you will learn how to graph piecewise functions by using your knowledge of graphing other functions. Let's review. When we graph, and we have any kind of inequality, we have to use open circles and closed circles. A closed circle is filled in. You will use it if you have less than or equal to, greater than or equal to, or an equal to. Basically, it has to have the bar underneath the inequality sign. When you have a closed circle, that means that the point is part of the graph.
Some of you are still getting this confused.
You can also have an open circle that is not filled in. You use this if you have greater than or less than. And the point is not part of the graph. We have a piecewise function. The definition of piecewise function is given by different expressions on various intervals. So, if we look at this, this is actually two functions put together. That's why it's piecewise. The first function is f of x equals negative x plus 1 when x is less than negative 1. The second one is f of x equals 2x when x is greater than or equal to negative 1. So if we have an x of 0, we would plug it into the second one because 0 is greater than negative 1. So f of x would be 2 times 0 or 0. So it depends what your x value is, which equation you plug into. These are called the expressions for the function. And we have constraints. A constraint is a limitation or a restriction. These are the constraint intervals. We want to graph our piecewise function. The first thing we do is to graph the first part of the function, which is f of x equals negative x plus 1 when x is less than negative 1. This is the graph of the function. F of
So I don't want you to totally graph yours right now, but I just want you to look at what did they do? They went to the y-intercept of 1, right? And then they have a negative 1 slope, so down 1 and over 1. Okay, don't graph yours totally yet because you're going to kind of see as they do this.
x equals negative x plus 1. We had our y-intercept at 1, so we started there, and then we had a slope of -1, which is down 1, right 1 from our y-intercept. But now we only want to keep the part of the graph where x is less than -1. So here's the line where x equals -1. And this is the part of the graph that we want to keep, the part that is less than -1. We do not want this part of the graph.
So pencil is going to be really important.
So that leads us to a graph that looks like this. We keep the part that we want to keep. We have an open circle where x equals -1, and this is because there is no bar or equal to as part of our inequality.
If you wanted to graph yours with that slope, you could.
We want to graph the second part of this function, which is f of x equals 2x when x is greater than or equal to -1. There is the line, f of x equals 2x. There is where x equals -1. We want the part that is greater than -1, which is this part of the line. And we do not want that part. So that yields us a graph that looks like this. Now this has a solid dot at the end because it has the equal sign. It's greater than or equal to -1. So -1 is part of this graph. So that gets a solid filled in dot. The final graph is a combination of the two. We have our first one, which was the -x plus 1 when x is less than -1. And here is our second one, which...
So on your paper, we're on page 22. You want to make sure at this point, which is at -1, 2, you have an open circle. How did I know that was at -1, 2? Because my y-intercept was 1 and it was a negative. Okay? So make sure you might have started at +1 for that y-intercept. And it was a negative slope. So at -1, 2, open circle, and you should be able to go up 1 and back 1 and continue to put those points along this one. For this second one, I might want to use my start point at 0, 0, because my y-intercept in this y equals 2x is at 0, 0. So at 0, 0, please put a point. Those of you who haven't put anything on your paper for your graphs, put something now. So 0, 0, you're going up 2 and over 1. But we're not going to extend this line going all the way down because we have this constraint that tells us that when it's at -1, that's when it changes. So as you finish that, kind of take a look at this.
Is 2x when x is greater than or equal to -1. This is our final graph. A common misunderstanding occurs when you do not use the constraints. We have the equation y equals -2 if x is less than -3. The constraint is x is less than -3. Here's the equation, or the graph, for the function y equals -2. But we have the constraint, so this is not the correct graph. The correct graph looks like this. It is where x is less than -3. It has an open circle because the point -3 is not part of this graph. In this lesson, you have...
So when we think about these different functions and graphs, as we looked at yours, if I was now looking at your paper, you should have made and filled in your graph so that it looks like this, right? And one thing I will tell you is that sometimes it helps some of you is that -1 is that you kind of think of this as being your dotted line. That's where the two have to change, right? Now, do you have to put that in for your constraint for where ours was? No, but for some of you, that's going to help you to make sure that you don't extend it past that, okay? So an open circle with a closed circle. You're going to be doing this. So did you need to know still your y-intercept of 0, 1? Yeah, 0, 1 was our start point and negative slope, meaning, so what we did in the first half of this unit, we're going to still keep using with that in slope-intercept. So, the top of the next page of your notes, as you are looking, you see many different examples of piecewise functions. So when we are looking at these different piecewise functions, this one's called the step function. You've seen that before. We've graphed that. This one is kind of what we were just looking at. A little different, where it says x is less than or x is greater or equal to 0. This time, this is our turning line. And then this last one has a couple of different functions. They're still functions, right? This one stops when we get to this value, which I'm not exactly sure. I think if you wanted to count over, it's like 6 or something. And at 2 here, we have an open circle. This is an open circle. And then notice right here, they have just this y equals 6 as 1 point. So if I asked you at when x equals 2, what is the value? You would want to tell me this 6. Even though there's an open circle up here and an open circle here, this is where the solution is. Whereas if I was asking you which equation you'd use if you were looking at x equaling 3, well, at x equals 3, you would be looking at this equation. So there's different equations that you're going to be looking at. They're going to all come in pieces as you look at this. Okay? So we are asked to graph this. It says the cost of renting a mountain bike is $25 for the first 3 hours. And then as we take a look at that, it says that the rate is $5 an hour for each additional hour after the first 3 hours. So the question is, if we only use it for part of an hour, they prorate it based on the $5 hourly rate. Write and graph a piecewise function for the cost of renting this bike. So hour 1, how much are you paying? 25. How much do you pay any more extra at hour 2? No. How about hour 3? No. So for hours 0 up till 3, you're paying what? 25. What does that equation look like? Y equals, and notice we're not going to just put the y equals again. We're just going to put y equals 25 here. That's for values what? 0 up to 0 to 3. Now, would we probably rent for 0 hours? No. So we might say greater than 0 for x and less or equal to 3. And if you put greater or equal to 0, I would take that. So please draw that line, right? And then what happens after that? Okay. So then each hour after that, it goes up by how much? By $5. So this is going to be a slanted line, right? That's my rate of change. This $5 an hour, that's like my slope. That's my m or my slope, right? That they're telling us. But when we write the equation, we got to be a little careful because we can't say that the equation is just going to be y equals 3x, right? And it's not 3x plus 25. So we need to be, or 5x. We need to be a little careful for that. So if we think of this one, when we are going up from here, do you agree that we would be going up $5 each time? Yeah. That our graph looks like this, and we're going to draw, and my guess isn't that you'd have it unlimited, but usually after a certain point in time, they're going to quit charging you maybe $25 or $5 an hour. This ordered pair is at $3.25. Agreed? Mm-hmm. Okay. So if we are going to write an equation, let's use that our slope was 5, and this is the point at 3.25. So if I was writing that using point slope form, I might start off and say y equals 5 times x minus 3, agreed? Mm-hmm. Plus 25. Now, a lot of times you might see this equation written, but sometimes they might simplify it. And I would say that this would be a nice, easy equation to write. This is for when x is what? Greater than 3, right? Because if it's equal to 3 hours, we still only have to pay 25. So this is when x is greater than 3. And if you're looking at this equation, if I don't ask you to simplify it and put it in slope-intercept form, which I don't think it does at this point, you can leave it like this. You're not going to put the y equals, you're just going to put the slope times this. Now, if you were distributing this out, like on the quiz and I asked you to write it in slope-intercept form, this would be 5x minus 15 plus 25. And my simplified equation would be, some of you forgot to put the y equals, and it would have been 5x plus 10. which if we would have continued this graph going down, we could see that it starts at y equals 5x plus 10, and it would go up from that point. Okay? All right. Next one is a step function on the top of the next page. When we look at this step function at the top of the next page, so as we look at this, it says the amount of income taxes for a single taxpayer owes in the U.S. depends on his or her income each year. The table shows the tax brackets that are different levels of income from 2012. Graph the function. So if we are looking at this, first off, when we are less than 379,000, when x is, if we read this, so sometimes people like to read the number first. We want to read this as the x first. When x is greater than 379,150, you're at 35%. So where's your 35% tax bracket, if we are looking at this? 35 is going to be, this would be 32, right? 34, 36. So 35. And we need to go to 379,000. Well, if this is 300, this looks like 325, right? 350, 375. So this is 375,000. So that's pretty close to ours. So you're going to go up from 375,000, and it has to be in the middle, right? Open or closed circle, would you say, because it says x is greater than? Open circle, right? How do I know it's open? Here's 32, 34, so 35. Oops, I put it in the wrong space, right? So I want to go at 35. It's in the middle. And anyone that makes more than 379,000, it's an open circle, and they're always paid 35%. Now, the reason I did that one is because this one's really hard, the 0 to 8,500. Because if this is 100,000, right, this is going to be 25,000, right, if we're looking at that. So where is, if I'm looking at 8,500, like, that's barely, like, right, like right here, right, maybe even not even that, right, because this one goes from 8,500 to 34. So at 10%, I want to have a closed circle at 0 up to a closed circle at 8,500. Not very far, right? Really small little line. Does that make sense? I'm going to the next one, and as I do the next one, I'm going from 8,500 to 34,000. So at 15%, that's going to be here, I need to have this being an open circle, right? That's at my 8,500. If I look at this, this is going to be open. This one's going to be closed at 34,000. Well, 34,000 isn't very far either, right? So this is 50,000, so it's going to be something like that, maybe in the middle. Really small little steps, right, that we're doing, okay? So what I would like you to do is approximate where you're 25 and where you're 28. This would have been your 15%, right, if we were looking at it. This would be your 25. This is at 28. Open up to the closed. So whenever we are looking at this, this is trying to tell you that it has to be closed. It could equal that. And when we are looking at the remainder of here, those are telling us it's open because it's not equal. Okay? You're exactly $83,600. Are you paying 25 or 28%? We should be paying 25 because it's equal here. Here it has to be greater than that amount. So if you earned $83,600.10, you're up the next tax bracket, right? That's what that's telling you. If you earn anything over that exact amount. So when you're thinking about those and you're looking for where your solutions are, okay? Now, this next one, as you look at the graph, and I know you don't have the f of x, so I want you to start with f of x, and then I want you to put this bracket. How many pieces in your graph do you see? How many pieces are we looking at? 1, 2, 3 pieces. What would you say? So I have this piece. When up to when what? When x is less, and if we are looking at this, I'm going to go with less than 1. Then I'm going to have from 1 to what? 1 to, where's this value? 1 to 2. Oh, so where x is greater than 1, and we're going to say, we'll say greater or equal to 1. And I'll talk about that in just a minute for when you put the greater or equal, or less or equal. And the other one we are going to say at this point is less or equal to 2. And then we have from 2 on, right? And so why does it matter if I have less or equal or greater or equal? In this one, it doesn't matter so much because at this point, it's in both solutions, and this is a solution to both. So when we look at this first part, can we tell what our y-intercept is? 3. Can we tell what our slope is? 1. So the first part of the function, when x is less than 1, is going to be y equals, if you like putting 1x, you could, but you could just leave it as x. This is my slope, plus what was the y-intercept? Plus 3. That is only going to be for when x is less or equal to 1. Then it stops, right? So notice I have this ray with the arrow continuing going. And this is, if I keep checking points on here, this point is at negative 1, 2. Negative 1, 2, if I plug in negative 1, that does equal f of x of 2. If I plug in this point way over here, my x-intercept of this one, negative 3, 0. If I plug in negative 3 for x, it would give me 0 for y. So all of those are points on my line. The second line, ooh, that's kind of ugly. How might we want to write it? Do we know points? This point is located where? 1, 4. Oh, so a lot of times when we write piecewise functions, we will write this in slope-intercept form. So if this is in slope-intercept form, we might want to start first in point-slope form. Can you count and tell me the slope of this line? M equals positive or negative slope? Negative. Negative how much? Down 6 over 1. So negative 6 is the slope. Does that make sense to everyone? So if I am writing for this second one, I'm going to just kind of write it up here because this one was being pieced if I'm looking at that. I have y equals my slope, negative 6. We're going to use point slope form. So please write this up above as well. Right in that other one, right there, the x plus 3. And we are going to put x minus 1 plus 4. Now when I multiply that, I'm going to have y equals negative 6x plus negative 6 times negative 1 gives me positive 6. But I have to add this 4 back here because I can tell it's definitely not at 6 for a y-intercept, which doesn't that make sense that it's probably way up here at 10? Y equals negative 6x plus 10. This question that I will have students ask me is if I have this answer, could I have written it in point slope form like this? And I probably would take both, but most of the time your answers, you're going to see them that they always write them in slope-intercept form, so they always simplify. Looking at our last one, what's a point on that line? This point is located at 2 and negative 2. So again, if I'm going to write it in point slope form, can I tell the slope of this last line when I start it? It's 1. The same slope as the first one, right? So I have y equals, if I'm looking at that, 1x. And now, could I think of just extending this and what should be my y-intercept if I would have kept going? Negative 4. So y equals 1x plus a negative 4, or if you wanted to just put minus 4. Could you have written this equation also in point slope form? Y equals 1 times x minus 2 minus 2. You still would have ended up with a negative 4, right, when we simplify this. So a lot of times we'll write it this way in slope-intercept form. So we're just going to keep pulling all that stuff you already learned about slope-intercept and point slope. So this next one, again, we have 3, give me your constraints first, okay? Give me your constraints back here. What is it going from each time? And I would say, because these all have a beginning and an end, you want to tell me x is in the middle. In the first one, they should both be less or equal and greater or equal. In the second one, not so much, right? So tell me your numbers, and then let's worry about doing the equations next. So write down those 2 for my first constraint. The second constraint, and they were equal, went from x being greater than what? -2 and less than 2. This one is less or equal to 4 because it's a closed circle at 4. And at 2 it is also a equal, greater or equal to 2. So thinking about my constraints first, all I'm doing is looking at my x values, okay? The constraints are where they're in between. Now, this is a horizontal line. All of them are horizontal lines. And the equation for a horizontal line is always y equals, in this case, f of x equals, what is the value of the first one? 4. What's the value of the second one? 2. And the last one is down at -3. Someone said, shouldn't I use y? No, we're talking about functions, and they're almost always for piecewise functions going to have f of x. And you don't write each one out as y equals 4, y. You don't do that. We just put them all with 1, and then we list our constraints together. We don't use the y, we're going to use f of x, okay? So when you're thinking about those. Questions on that one? Okay. And those of you that, when I look at your homework, make sure, like here, that I can see 3 distinct ones. Here I can see 2 of them. Right? Here I know at x less 3 that this is where the change is going to happen, right? This one, I know there's going to be something different at -2, right? If I'm looking at that, there's going to be something different at 2, and then greater than 2. So there's going to be 3 pieces of my graph as you are taking a look at those.